first, I would like to first by thanking Erie Hack for allowing me to present this presentation. It's a very kind of laid back presentation. So if you have any questions, feel free to type in the chat and I'll address them accordingly. And this presentation in particularly is a workshop for helping anyone who's interested in using IoT sensors, in particular the affordable IoT sensors that I will mention later what they are. And this is quite a great opportunity for anyone to get into this now. And it's definitely a unprecedented opportunity for anyone to kind of get into this water resource monitoring using the new next generation sensors that are coming up very rapidly. And I hope that you will enjoy this presentation and hope you find it helpful. So let me get into that. This first slide kind of shows you what the problem is right now. There are a lot of traditional water sensors that are being deployed by various agencies out there and also universities. These are kind of like the state of art, cream of the crop sensors, if you will. They are very reliable. They are field tested, but they are very expensive at the same time. So on the left side, you can see that they are the water level sensors. These are the radar water level sensors. They are used a lot by USGS to measure water levels across the nation. These are utilize radar technologies, and they are proven, but they come at a cost. So you have to pay around $1,000 to purchase these equipment and then mount them. So that kind of restricts the budgetary limits. And then on the right-hand side is an example of a water quality sensor. These are, if you are familiar with YSI companies, these are very kind of state-of-the-art, standardized water quality sensors that measures a variety of different parameters, pH, DO, so on and so forth. And these sensors are also very reliable, field tested, and the only kind of downside is the initial purchasing price is very expensive. They can go to around $12,000 if you wanted to kind of measure a lot of different parameters. The price just goes up from there. So this kind of creates a spatial problem, if you will. So on the left, I'm showing you the depths of the Lake Erie, the lake bed depth at different locations. And as you can see, the Lake Erie, as an example, is a very spatially dynamic lake. So the water is changing dynamically at different locations. But because the sensors that we are deploying are very expensive, what resulted is on the right-hand side, on the top, I'm showing you the different buoy that are deployed, that are online right now. So you can see these are kind of scattered around Lake Erie, and it doesn't measure kind of like the spatial variations of different water qualities because Lake Erie is very dynamic. So that creates a challenge, and especially if we wanted to kind of model different, for example, hypoxia or harmful algal bloom. These are very spatially dynamic events, and in order to kind of accurately predict these, we can, if we can spatially kind of have more sensors in the Lake Erie, the models can then be more accurately predicted. So that's kind of a challenge right now with the high cost sensors. And then on the bottom right, that shows you the current USGS monitoring of the different streams, the different stream gauges. As you can see also, the streams themselves don't necessarily have a systematic monitoring network. For example, if you follow my mouse here, this stream here, there's only one gauge on there. And if someone wanted to monitor like the spatial variation along the stream corridor, that's not possible because the sensors are quite expensive to deploy. So what is happening now is there is a new generation of more affordable sensors coming out online, and these kind of started recently. And on the left side, I'm showing you an example of water level sensors using ultrasonic sensing technology. And these cost much less, actually 10 times less than the USGS radar sensors. And these can be deployed anywhere, and it's much cheaper. And on the right-hand side, I'm showing you another example of more affordable water quality sensors. These cost around $1,500, and they are very comparable to the Y-side sensors, and they are also 10 times cheaper than the Y-side sensors. So these new generation of sensors and more affordable sensors kind of opens the door to more sensors being deployed in an affordable way. And also we can not only have more data, but also kind of have more people get into the using these sensors for monitoring various water resource means. And the other innovation that is happening quite rapidly is the Internet of Things. Specifically, I'm showing you this new technology called LoRaWAN. And this is, in comparison, it's to cellular, so like the telecommunication our phone use, or Wi-Fi, or Bluetooth. It used very little power. So you can see the blue bar is the amount of power that LoRaWAN use. It's saying ultra low. So it doesn't require a lot of power. So you can literally just put a 5-volt battery connected to a sensor, and then it can last for years, comparing to a sensor that use, say, a cellular network. So this opens up a new approach for sensing. And then in comparing to other network, you can see on the left bottom graph, LoRaWAN is also a very promising technology because it transmits very far while it uses very little power. So this is kind of the next generation of sensors, meaning that it not only saves the amount of battery that you're using, but also you can transmit very far in comparing to, say, a cellular network or Wi-Fi network. So this is kind of another technology innovation that is happening. And the speed of IoT sensors, not only just using LoRaWAN, but also networks, is also picking up. This is statistics that I just picked from online. You can see these just astronomically large numbers that are increasing kind of every year. And it's not going to slow down. And what this does is it also opens up a new kind of new groups of sensors, if you will, that is not only affordable, but also utilize this new generation of technology that not only require less power, but also transmits further. So it kind of improve based on the traditional sensors a lot, and give us more affordable means to measure more, spatially more parameters for water resource monitoring. So, well, everything is great. We have all these technologies. Everything's picking up rapidly. So one would say, this is great. I really wanted to get into it. So what should I do? So this, I'm just showing you an analogy. This is a wall of different technologies of the new IoT sensors that were deployed or developed through the LoRaWAN network. And if someone would get into it, there are literally thousands and thousands of different possible things that you can do with it. The key question is, if someone wanted to start with these, where do they even get started? So that's where I kind of did some work here to help with teaching folks about how to get started, and with the different examples and quick start guides. This workshop is gonna present to you how these kits and different training materials that I've recently developed can help you kind of walk into and open the door into this new generation of sensors. So I, with the help with Liminal Tech staff, and I was able to develop a kit that is just $300, and you can kind of kickstart with this kit to monitor a variety of water-related things: water temperature, water level, and then different air atmospheric parameters. And the kit itself involves mainly 3 different things: the sensor themselves, the networking of the sensors, so there will be a gateway that connect to the internet. And then the last part is the data, which is you are transmitting all the data into a real-time data dashboard that you can show anyone what the data looks like. And just a quick note, these things can be replaced with any component you want. So the $300 sensor kit is trying to kind of teach you the various different critical components that is inside of this new technology or new generation of sensor, how they work. But later on, if you want to really dig into it, you can literally replace it with anything you want to modify for your own case. So just want to show you what the sensors looks like. These are very kind of cheap sensors if you compare it to the state-of-the-art sensors I showed you earlier. On the left side, these are kind of the housings for air temperature, relative humidity. The sensor itself is mounted inside a radiation shield. And then the sensor is communicated to this black box, which is a sensor that's communicating and transmitting through LoRaWAN network. And eventually the data can be showed up on the dashboard, which I will show later. And then in the middle here, this is a water level sensor. It also uses LoRaWAN, and it utilizes this very similar mounting mechanisms like this black box here that's inside this tube, and then you can mount this water level sensor anywhere that you see fit. For the water temperature sensor here in the middle, this is the temperature sensor you're seeing in the bottom here. this is where the temperature sensor is, and then it's mounted all the way up to a transmitter, which is very similar to the black unit there. And then this whole entire housing can be placed anywhere that you want to measure water level if you want. So this entire kit costs around $300. And one other thing I didn't show here is the gateway unit, which kind of collects all the data coming from these different sensors and then push those data into the cloud. And that's something I'll show you in the later in more details about those. But these are on the right-hand side. These are the photos, what the sensors looks like in the field. They can mount it very in a decentralized manner, if you will. So they can mount it by themselves on a pole. This is located at Liminal Tech here in Ann Arbor. We have a pond nearby, and we just mounted these sensors there to test how they work. So those just give you a sense of what they look like. So this is kind of a typical kind of setup for the $300 sensor kit. You can have a centralized connection. So you say you wanted to connect all of these different sensors to the internet. This is kind of like a typical setup. You can have a gateway unit inside somewhere near the sensor or far away, depends on the transmission limitations. And you can just put this gateway somewhere, and then you can connect the power and Ethernet to the gateway so it can communicate to the internet. And then you can have the antenna connected to the gateway, which will let it communicate. So let the gateway communicate with the different sensors in the field. So this is a very kind of different setup, if you will, from other traditional setup, because prior setups you would have the sensors themselves connected to a cell modem, and then or physically connect these sensors to other data loggers, and then communicate individually for these sensors to communicate to online. And this setup saves a lot of kind of complexity to the traditional setup, because you no longer need to physically hardwire these sensors into somewhere like a data logger. You can literally just wirelessly communicate these sensors to a gateway, and then the gateway will push all the data to the cloud where all the data is stored. So this kind of takes out the data logger entirely for this setup. So with this kit, there is also possibility to do real-time data visualizations as well. And the real-time component is possible through the gateway setup I showed in the previous slide. And you can set up to kind of push data from these sensors to any platform you want. In this case, I'm showing you Ubidots, but you can also push it to other data visualization or cloud platforms out there. Depends on your pricing limit or budget limit. But this page, you can literally just develop it very in a very convenient way, and then you can share this page to anyone you want through like a website, and it's fairly easy, I would say, the process to set up this website, and it's very customizable through the Ubidots dashboard. So with this, I'm just showing you some examples of deployment of these sensor kits, just to give you an example or give you a sense of what the sensors can be deployed. And hopefully Google Earth opens up here. While waiting for this, I'm just gonna explain quickly if this doesn't open. Basically, for these sensor kits, it can be deployed anywhere, in a pond or near a pond to measure kind of water level for the pond, but it can also measure, say, if you want to mount these sensors on like a floating structure and put them in a lake, you can measure, like, for example, the water temperature profile inside the lake. But these are very customizable, as I mentioned before. So yeah, I guess Google Earth doesn't want to work here. So this slide will be shared later, so you can click around these links, so you don't have to type all these long links. But if you want to get more details about the examples that we deploy so far, feel free to look into this slide and dig around the different examples there. So with the kit themselves, you can definitely learn more about them through a quick start guide that I developed on Hackster.io. This kind of walks you through all the different components that you need to purchase, you need to assemble for this kit. And just to show you the contents, these are different hardware components and then different tools that you need. Along with it, there's also YouTube training videos on how to connecting the different pieces, such as connecting the gateways, so on and so forth. So these are hopefully detailed enough to get you started with these kits. And yeah, feel free to let me know if you have any questions using these. The main goal is to kind of teach you and get you started with these new sensor kits. And as I mentioned before, there's also extensive YouTube channel training materials as well, and this is also kind of made through my work here, and this is being constantly updated because if you work with sensors, a lot of the sensors are also being upgraded as well, so a lot of these instructions need to be kept up to date. And I also try to add more videos on how to use these sensor kits in different environments. So when I deploy in a new setting, I will try to get more training material to be published on this site as well. So those are the training materials. And you might be asking, why is this relevant to Erie Hack? Well, there is a Erie Hack mini challenge, and you can read more about it on this Google document that Felicia has posted before. The challenge itself is called, I believe the
water sensor kit.
Yeah, the water sensor kit. Thank you. So essentially, what we are looking for is anyone who are interested in using these sensors and also kind of hack into it. I mean, quote unquote, hack into it and then improve these sensors. And what we envision is if we know this kid is not perfect, and if you are, interested in hardware improvements, you can literally purchase these kits and then, add your own Arduino board or connect to water quality sensors that you are interested in using. And you can improve upon these $300 sensor kits. And then the other hacking challenge that we have for these kits is we wanted to see if anyone can come up any innovative use of these sensor kits. So if you know of any area of interest that that need to monitor, these different parameters, if you can, deploy these things, or even have a proposal to kind of put these in, we are very interested in learning or seeing those proposals or deployment examples, and we'll definitely consider those during the mini challenge process. One good thing about this mini challenge in particular is you will be reimbursed for any of the components that you purchase for these kits. So if you're interested in using, or if you're interested in participating in this mini challenge for your ear hack project, you will be reimbursed entirely for any of the components you purchase. So hopefully that will help with getting you started with this mini challenge work. So any questions before I address the online questions here? Any questions from the audience is here?
There were some questions in the chat, so like the time frame of the mini challenge, and that will be between semifinals and finals. We'll be looking at different ideas that fit different mini challenges, and we'll be awarding them at around finals time. And just to clarify, Jeff, for this mini challenge, like folks can directly reach out to you, correct?
Yes. Yep.
What other questions are there?
Yeah, George, thank you for sharing that, the cellular modem. I'm definitely aware of that as well. So that's yet another example of the IoT, rapid IoT innovation that is happening. And as I mentioned before, you can, replace any of the components, the LoRaWAN, with, cellular modem to fit your own needs there.
One of the engineers who works at Blues had a Hexter IO session where he built a this is actually how I found out about Erie Hack. He built a water sensor for a river, I think it was in Missouri, near him, and it sort of got me going on it. But I can find a link to that and I'll put it up here. It was pretty good. It was actually called something like "Don't make these 5 mistakes when you build your water sensor" or something like that. It was he put it together nicely. But I'll share the link.
Yeah, we actually we collaborated to host that webinar, but I'm so glad that that is how you found out about Erie Hack, George. That's so awesome.
Well, it's actually, I have another project I'm probably going to use Blues wireless stuff on. I'm actually working with a company here in Buffalo that they got 3,500 electric bicycles from Uber when they got after Jump started, and they have a program to roll out programs in multiple cities to provide cheaper or free transportation for economically disadvantaged people. So I was already investigating Blues for that, and it's like, oh, here's another cool thing to do.
That's awesome. Well, there's one other question, Jeff. Can you share the specs of the sensors?
Oh, yes, yeah, absolutely. So if you go into the link for the the quick start guide. Let me just show you quickly. These should have the exact sensors that I use. And if they don't, then they are also in the YouTube training videos, and in the under the descriptions for the training videos, they should have the different sensors that I utilized. But yeah, as always, if you have questions on those, feel free to contact me directly. I can let you know very easily.
Put Jeff's email in the chat, and I'll send my email.
Thank you. So the time frame for the mini challenge, Felicia, is that a question that you can address?
Yes, I already addressed it earlier.
Oh yeah, yeah.
I
Thanks.
believe there was another. I believe there is another question. Is it Mehdi?
Hello, can I unmute myself? Sorry, this is Mehdi Ramati, faculty member, CSU. Sorry, I was disconnected initially when you get into my question, so I just missed the first part because of unstable connection. Sorry about that. So thank you, Jeff, for the very, very interesting talk. I really enjoyed that, and I definitely will get in touch with you about the sensors. My question, I guess, is about the way that you deploy the sensors, because one thing is, as you mentioned, is the sensing part, and then the second thing is the processing, and the third thing is the communication that you use LoRaWAN. It's a kind of low power, long distance method of communication. Absolutely. So what about the sensing part? Is there any flexibility to kind of be adaptive in a way that you do, like changing the temporal resolution? At least I know there was no special resolution, as you mentioned, but what about the temporal resolution? Can we change it? Is there any flexibility to be adaptive in that manner?
Yes, yeah. So in particular, this $300 kit, these sensors in the black box here, these are you can modify the temporal resolution very easily. You can change it to any time resolution you want, whether it's 30 seconds or an hour, so on and so forth. And the great thing about these is, as I mentioned before, you don't necessarily need a data logger. As to traditional setup, you need to kind of log your data as you go. These kind of just push the data real time, and then eventually all the data are stored in the cloud, so you can visualize or download them.
Awesome, that's great. Also, the water temperature, is it kind of flexible range depth that you take it, or can be adaptively as well from that perspective? I mean, where do you place the sensor in the bottom to get a kind of vertical profile of temperature, for example?
Yes, so that's something I worked on recently with Liminal Tech staff here, and we essentially just have 3 of these mounted in kind of one enclosure, if you will, and then you can do a string kind of attach along, if you can imagine a string running down here, and then different temperature sensors attached at different levels, and obviously you need to do some kind of waterproofing or weatherproofing to that, but we've made something like that, and it's definitely possible to measure water profile, which is very important for lakes.
Absolutely, yeah. Thank you so much. Looking forward to working with you, Jeff.
Thank you. Let me see if I think I've addressed all the questions here. Any other questions?
I don't have any questions at this point, but I will get in touch with you if I do. yeah, I'm sure I'll be in touch with you. I'm not sure if it'll be questions or what, but thanks. This was awesome, by the way.
Thank
Yeah.
you. Yeah, feel free.
Thanks,
Feedback.
Jeff, for putting on this workshop. This is very, very, very informative. You have our emails. I will send over the slides and with that, the links as well to in those slides. And feel free to reach out if you have any questions for Jeff around the sensors, and feel free to reach out if you have any questions about mini challenges from me and just, in general, further collaboration with CWA.
I do have just one other kind of stupid thing. I want to say this picture back here, I took it.
I think I remember that from your quarterfinals. Cool. I will definitely share the slides.